Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for rotating linked list. Let's look at the problem description. We are given the head of a linked list and we have to rotate the linked list to the right by k places. Let's take a look at the example 1. So the linked list has 5 elements 1, 2, 3, 4, 5 and we have to rotate to the right by 2 places. The first rotation, the 5 will become head and the 4 become tail, and the second rotation the 4 is moved as a head of the linked list and 3 will become a tail. So the final list will be 4, 5, 1, 2, 3. Let's take a look at the example 2. So the given linked list has 3 elements. Here they are shifting the elements 4 times. Instead we can do this efficiently. If we rotate this linked list 3 times, we get the original list again. Okay, so all we have to do is we have to just rotate only once. If the k is greater than the size of the linked list, then we have to take k mod the size of the linked list so that we can perform only few shift operations. So in this case 4 mod 3 is 1, so we just shift only once, so we get the same result. So 2 will become head and 1 will become tail, so 2, 0, 1. So that is the final output. The constraints for this problem are the number of nodes in the list is in the range from 0 to 500 and the value of each node is ranging from -100 to 100 and the number of shift operation is ranging from 0 to 2 times 10 to the power 9. Let's look at the approach to solve this problem. We are given this linked list with 5 elements and we have to rotate that linked list to the right 2 times. So after rotating, these 2 elements will be moved to the beginning of the linked list. So we get 4, 5, 1, 2, 3. So each time we rotate, the last element will become a head. Okay. So the brute force approach will be traverse this linked list k times. Each time move tail node to the beginning of the linked list as a head. So for a huge value of k, this approach is inefficient. Instead what we can do is locate the first element in the last k elements of this linked list. For example, in this case the k value is 2. So the first element of the last 2 element is 4. So we have to locate this node. After locating that node, we have to link the tail node and the head node. So the 5 to 1. Okay. And then we have to remove the link between the node 3 and 4. Okay. And then make this node as the new head of the shifted linked list. First we link the tail and the head and then locate the second node from the tail and make that as a new head and then remove this link. Then finally we get this shifted linked list. That's what I have written here. First we traverse the linked list and locate the tail node, and then as we traverse, count the number of nodes in the linked list. Then once we locate the tail node, link the tail node with the head. Once the loop is formed, next thing we have to do is locate the new tail node after that is present at count minus k nodes away from the current head. For example, this is the tail node. So this node is located at 3rd position, which is equal to 5 minus the number of shift we are supposed to perform. So 5 count minus k will give us the position of the new tail node. Okay. So that's what the new tail node located at the count minus k nodes away from the current head. Then traverse count minus k nodes from the head and set the last node visited as the tail, new tail. Next, set the next node of this new tail node as the new head and then remove this link. Then return this new head as the head of the shifted linked list. Let's look at the flow chart. Input for this procedure is the head of the linked list and the number of shift to be done. First we initialize the new head and the current tail and the count variables. So the new head will be initialized with null, the current tail will be initialized with head, and the count is initialized with value 1. Okay. First we check whether the list is empty or it has only one node. If that is true, then we assign the head to the new head and then return the new head. Otherwise, we traverse that linked list and locate the tail node of the linked list. As part of that, we keep track of the number of nodes present in that linked list by incrementing the count variable. Okay. So once we compute the number of nodes in the linked list, sometimes the number of shift operation is greater than the number of nodes in the linked list. So to do the shift operation efficiently, we have to update the value of k by doing k mod count. Okay. Then we link the current tail node to the head. Basically we form a cycle. Next we prepare for the second traversal to locate the new tail node. Okay. So first initialize the new tail with head, and we have to process only the count minus k number of nodes to locate the new tail. Okay. So in this each iteration we for advance the new tail nodes pointer and we decrement the count. Okay. So once we locate the new tail, then the next node followed by the new tail will be the new head. So that's why we assign the new tail dot next to new head, and then we make that next pointer of that new tail node to null. Okay. Then finally we return the new head as the head of the linked list where the elements are shifted, k positions. Let's move on to coding. First I check whether the head is null or the head is the only element in the linked list. If that is true, then I return the head. Next I initialize the current tail pointer with head pointer's value and then initialize the count to 1. Next I write the for loop. This will locate the tail node in the current linked list. So each iteration I advance the current tail pointer and increment the count variable. Then I update the value of k by doing k mod count. This is for the case where value of k is greater than the number of nodes in the linked list. Next I link the tail node with the head. Next I am initializing the new tail pointer with the head, and then this for loop will locate the new tail node in the shifted linked list. Basically this will run count minus k times. Each time I advance the new tail pointer and then decrement the count variable. Once I locate the new tail pointer, then I initialize the new head pointer with the next node of the new tail node. Then I remove the link from the new tail to the next node, and then finally I return the new head as the head of the shifted linked list. Next I am going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given the linked list with 5 nodes and we have to rotate that node 2 times. The node 1 is the head and the node 5 is the tail. First we check whether the head is null or the head next is null. This linked list is not null and it has more than one node. So we go ahead and initialize the current tail pointer with the head node. So the current tail is pointing to 1 and the count is initialized with 1. And then the iteration 1, when we enter, the current is 1 and the count is 1. And when we leave this iteration, we update the current tail pointer to point to the next and then we increment the count. So the current tail now points to 2 and the count is 2. And here in this iterations, when at the end of this iteration, the current tail points to 3 and the number of nodes in the linked list so far accounted as 3. And in the iteration 2, at the end of that iteration, the current tail points to the node 4 and the count is 4. And in the iteration 3, the current tail points to node 5 and the total number of nodes is 5. The current node's next pointer is null. We break out of this loop and so we found the total number of nodes in this linked list is 5. Then we update the value of k by doing k mod count and then we link the tail to the head. So that's what we are doing here. So that we update the current tail's next pointer to point to the head node. Okay, basically we form the cycle. So the next we have to find the new tail node in the shifted linked list. So in this case basically we have to locate this node. Okay. So we traverse the linked list count minus k times. So count is 5 and k is 2. So basically this loop perform 2 iterations. Okay. So in the iteration 0, so the new tail points to 1 and the count is 5 and value of k is 2. Okay. Because the 5 minus 2 is greater than 1, so we go ahead and update the new tail pointer. Basically we advance the new tail pointer to point to the second node and then we decrement the count. So the count becomes 4. Again here we check 4 minus 2 is greater than 1, that is true. So we advance the new tail pointer to point to the node 3 and then we decrement the count. So the count becomes 3. And then in the iteration 2, 3 minus 2 is equal to 1. So this condition fails. So we come out of the loop. Okay. So basically we locate the new tail of the shifted linked list. Next we have to set the new head pointer by assigning the new tail node's next pointer. So new tail's next pointer is 4. So this will be set as the new head. And then we have to remove the link between the node 3 and 4. So we are setting null for this node's next pointer. So this link is removed. So finally the linked list will be like 4, 5, 1, 2, 3. So 4, 5, 1, 2, 3. Okay. And then we return new head as the output. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity for this procedure is order of n. So let's take a look at the case 1. The linked list has 5 elements. We have to shift 2 times. Okay. So in this, the first for loop performs 4 iteration and the second for loop performs 2 iterations. Okay. So if there are n elements, then the first for loop performs n minus 1 iterations, the second for loop performs n minus k iteration. Okay. So the time complexity is order of n minus 1 and we remove the constant factor out. So it will be order of n. The space complexity is order of 1 because we are not allocating any additional space. So we just use only few variables. So the space complexity is order of 1. Thanks for watching this video. Have a great day.